I got a file f1.txt, right? f1.txt, right? Of 192 MB, right? Into how many blocks? Number of blocks. (192/64), right? How many blocks? Like 3 blocks. It is divided into 3 blocks. B1, B2, and B3. B1, B2, and B3. How these blocks are going to get distributed across the slaves? The single master and multiple slaves, right? Think that you have got slaves, 3 slaves. Slave 1, slave 2, slave 3, right? Okay. S1, S2, and S3, right? Okay. This is the name node or the master node, right? Name node or the master node. So F1 dot, see here, B1 stored here, B2 here, B3 here, right? So here, think like you have got some 30 lakh records, 30 lakh records, 10 lakh in this, 10 lakhs in this, 10 lakhs in this, right? Yes. B1 has got 10 lakh, B2 has got 10 lakh, B3 has got 10 lakh. Okay, F1.txt. F1.txt into how many blocks? B1, B2, and B3. B1 stored in S1, B2 in S2, B3 in S3, right? Yes. B1 in S1, B2 in S2, B3 in S3, right? This is how the data storage. Now, data processing, right? Okay. Job is to process f1.txt, right? F1.txt into how many blocks? Into how many tasks? Job always defines into number of tasks. Jobs always divide into number of tasks. Into how many tasks means it always depends on number of unique blocks. Number of unique blocks, right? Yes. Number of tasks equal to number of unique blocks into how many blocks? Number of unique blocks into how many blocks means, right? Like 3 blocks. 3 blocks means 3 tasks, T1, T2, T3. Job is to process f1.txt. Yes. Into how many? T1 task, T2, and T3. T1 for executing the B1, right? T1 for executing B1, right? Yes, if there are 10 blocks, then the tasks will be 10, right? Yes. If there are 10 tasks, then there will be 10 tasks, right? Yes. Okay, T1 for executing B1, T2 for executing B2, T3 for executing B3 block, right? Okay. Who should execute this T1 task? Slave 1. Who should execute this T2 task? S2. Who should execute this T3? S3. T1 S1. Okay. T1 should be executed by slave. What is the task 1 to be executed by slave 1? T2 by S2, T3 by S3. So here T1 task given to S1, T2 to S2, T3 to S3. Okay, in this way. Okay, this is what we have discussed, right? Okay, fine. So T1, T2, T3 tasks are executed by the three slaves S1, S2, S3 parallelly. So during this execution, right? T1, T1, three tasks are executed by the three slaves parallelly, right? When three tasks are executed by the three slaves parallelly, then during this process, suddenly if any slave goes down, during this process, if any slave goes down, right? Then here you are seeing like two drawbacks, right? Here you are seeing like two drawbacks. One is this 10 lakh records are lost. One is data lost. Second is one, the task gets failed. The task gets failed, right? There is a task failure. It means the job also gets failed, right? Fine. Two things you can observe here. The task gets failed. Second is that data gets lost. Two things you can observe right here. Okay. So in such case, how Hadoop is able to overcome this kind of situation is it's going good way. We got a concept called replication and fault tolerance. How to overcome such kind of, so Hadoop is coming with a concept called a replication and fault tolerance. Replication and fault tolerance, right? Yes. Replication and fault tolerance. Replication, nothing but a duplication. Replication is nothing but duplication. Default number of replicas. Replication is nothing but duplication. Default number of replicas in Hadoop, right? 3. Default number of replicas means 3. Default number of replications, that is replicas, is 3. We can configure. Okay. It is like backup. Yes, it is like backup. Yes. By replication, nothing but duplication, right? Yes. We can also configure the replication. We can also configure means increase or decrease, right? Increase or decrease. We can also configure increase or decrease the replications, right? We can also configure increase or decrease the replications. So I'll just show you like how to configure increase or decrease later once we discuss this example. Yes, just now observe this. How these replications are applied, how the replications are applied, right? So to the file it is applied or to the blocks which is applied, right? Observe this. For example, I got a file like this. For example, f1.txt file, f1.txt, right? f1.txt file, like 192 MB, right? 192 MB. So number of blocks into how many blocks? Number of blocks equal to file size by default block size, right? That is into 3 blocks, right? B1, B2, and B3, right? B1 replicated by 3 times, B2 replicated by 3 times, B3 replicated by 3 times, right? Totally into 9 blocks you are going to get. Replication means duplication. The blocks getting duplicated. So B1 by 3, B2 by 3, B3 by 3, totally 9 blocks, right? You are going to see what? 9 blocks. How these 9 blocks going to get distributed across the slaves, right? This is my master node. These are my slaves. I got 3 slaves, right? Yes. Slave 1, slave 2, and slave 3, right? Yes. B1 here, how these 9 blocks are going to get distributed across the 3 slaves? B1 here, B2 here, yes. B1 here, B2 here, and B3 here, right? Observe. B1, B2, B3. B1, B2, and B3. B1, B2, and B3. In this way, right? B1, B2, B3. In this way, right? Yes. B1, B2, B3, B1, B2, B3, B1, B2, B3. This is how the data is getting. Okay. f1.txt divided into how many blocks, right? How many blocks? B1, B2, B3. Where B1 stored in S1, also in S2, and also in S3. B2 also in S1, in S2, and S3. B3 also in S1, S2, and S3, right? So 3 blocks distributed across the multiple slaves, right? The 3 blocks, right? B1, B2, B3. B1 distributed across the slaves, B2 also distributed across the slaves, B3 also distributed across the slaves, right? Multiple slaves, right? B1 replicated by 3 times, B2 also replicated. Okay. Next, observe. This is how data storage happening, right? Now data processing. Job is to process f1.txt into how many tasks? Number of tasks. Into how many tasks? Job is divided into tasks, into number of tasks. Number of tasks always depends on number of unique blocks. Number of tasks always depends on number of unique blocks, right? Why I'm saying the unique blocks means here number of unique blocks. How many? 9 blocks or 3 blocks? Here, what is that? 9 blocks or 3 blocks?
3 blocks. 3 blocks, sir.
3 blocks, right? Here, that's why I was saying that unique blocks means not this 9 blocks. 9 is a duplicated blocks. 3 blocks only. Unique blocks are only 3. Duplicate blocks are 9, right? Only number of unique blocks are only 3. Unique blocks are only 3, right? Yes. Now, job is to process f1.txt. Yes. Job is to process f1.txt. So divide into how many tasks? T1, T2, T3. T1, T2, and T3, right? T1 for executing, okay, T1 for executing B1. T1 task is for executing B1. T2 task is for executing B2. T3 is for executing B3. Who should execute this T1 task? In the last previous example, T1 task could be executed by only S1. Now, T1 can be executed by S1, S2, and S3, right? Yes. T1 now T1 task can be executed by previously T1 can be executed by only slave 1. Now T1 S1 can execute, S2 can execute, S3 can execute, right? Previously B1 block is present in S1. B1 block is present in S1, right? So S1 only should have, but here B1 present in S1, S2, S3. So B1 is present in S1, in S2, in S3. So who should execute this T1 task? Means S1 can execute, S2 can execute, and S3 can execute, right? All these 3 can execute. T1, S1, S2, and S3. Fine. T2 task. Who should execute this T2 task? S1 can execute, S2 can execute, S3 can execute. T3 also S1 or S2 or S3. So assume master node is selecting S1. So for executing this T1 task, S1 node is selected. Assume master node is selecting S1 only for executing the T1 task. Okay. Who should execute this T2 task? So T2 task, assume that master node has selected slave 2 only, assume, for executing this T2 task. For executing the T3 task, assume S3 only selected. So for T1 task, S1 selected. For T2 task, S2 selected. For T3 task, S3 selected. Assume T1 task to be executed by slave 1, T2 by S2, T3 by S3. Okay. So when the three tasks T1, T2, T3 executing by the three slaves S1, S2, S3, suddenly if the slave S2 is down, do you think the data is lost? T2 task is for executing B2 block, right? Still the B2 is available. Still the B2 is available, right? The B2 block is available in S1 and S3, right? There is no data loss here, right?
Yes, sir. Yeah.
Fine. So there is no data loss here. Yes. There is, the first thing is there is no data loss. Still that a B2 block is present in S1 and S3. Second thing is the T2 task can be assigned to, as the B2 block is present in S1 and S3, both S1 and S3 can execute the T2 task also, right? Any one slave, that is T1 or that is S1 or S3, need to perform two tasks, to execute two tasks, or if any it is available, any other new slaves are available, then it can do that, right? So what is your observation? There is no data loss. There is no data loss. And
So what if out of 3, 2 fails, or it will be dependent on only one slave, right?
still there is no data loss, right? And still, but generally, I'm taking a very small file size, right? If you take a very big, if you've got a very big cluster of 40 nodes, 40 slaves, or 30 slaves, right? Yes, 40 slaves or 30 slaves or 60 slaves, right? So then if one or two goes down, right, still you've got you can execute that task in other slaves, right?
Okay, sir. So one question. 2 days back, you told that number of blocks divided by 128, right? In the latest version of Hadoop something.
Yes, yes.
Yeah, then here you are telling 64.
Assume if you
Okay.
assume that default block size is 64. If 128 means the blocks will change.
Okay.
And if it assume that if it is 128, whatever it is, if you're using 64 as a block size or 128, if you got some blocks, right? The blocks how they are distributed, right? If you're using 64 or 128, even you can use your own block size, right? Some 100 or 75. So whatever it is, default block size is what? Either it is 64 or 100 or 75, whatever it is, how many blocks you got, how the blocks are distributed, right? That is important.
Thank you, sir.
So here there is no data loss till the data is available in other slaves, and the task T2 can be executed by either S1 or S3, right? So any one slave need to execute multiple tasks. Here, observe, here the T2 task will be assigned to which slave, S1 or S3. What criteria is followed in assigning the task T2 to the slave? If there is any slave goes down, then the T2 task will be assigned to whom, S1 or S3. What is the criteria followed there? That is one query. And one here T1 task, when it is slave 1, slave 2, slave 3, all are eligible to execute T1 task. Then why the preference is given to slave 1 only? What criteria is followed in assigning the task to the slaves? First, why that the priority is given to T2 task, also why it was given to S2, why not to S1 or S3? T3 task, what criteria is followed in assigning the task during the first time allotment, or if any slave failure at that time, if you want to reassign the task to any other slaves, what is the criteria followed, right? Fine. So here in this case, right, in this case, So here, right, one second. We have got 4 steps criteria followed, right? So once again, just observe. Here I'm writing S1 executing the T1 task. So here S1 executing T1 task, S2 executing T2, S3 executing T3, right? Yes. So here S1 executing T1, S2 executing T2, S3 executing T3 task. Okay. For example, S2 is down. Then T2 task assigned to which? S1 or S3? To S1 or S3, right? To whom? T2 task assigned to S1 or S3, right? What is your answer?
It can be any of it.
Okay. Here 4 steps criteria is followed, right? 4 steps criteria. Hmm. 4 steps criteria is followed, right? Okay. First one. Master node selects the slave. Master node selects the slave which is highly configured. Which is highly configured, right? Means which has got good hardware configuration. Master node selects the slave which has name no master node selects the slave which is highly configured. If both the slaves have got high configuration, assume if both the slaves, think if the S1 has got high configuration than S3, right? Then the task will be assigned to S1. Okay. If S1 has got is highly configured than S3, then the task will be assigned to S1. If both the assume if both the slaves are highly configured, if both the slaves are highly configured or equally configured, right? Or highly configured, right? Then master node selects the slave which is more ideal. Master node selects the slave which is more ideal. Master node selects the slave which is more ideal, right? Yes. Which is more ideal means which is more free. Master node selects the slave which is more ideal or free. If both the slaves are free, assume if both the slaves are free, then in that case, if which is more ideal means, for example, S1 executing 3 tasks, S3 executing only 1 task, right? Now the task will be assigned to S3 as it is executing very less tasks, right? Okay. If both the slaves are free, assume if both the slaves are free, then master node selects the slave master node selects the slave which is nearest to it, right? Yes. Master node selects the slave which is nearest to it. Think all the slaves are at the same place. If all the slaves are at the same place, if both the slaves are equally near, if both the slaves are equally near, right? Equally near, then in the master node selects the slave. Master node selects the slave which has good health status, Master node selects the slave which has good health status. If both the slaves have got good health status, master node selects the slave which has good health status. If both the slaves have got a good health status means if one slave have got some physical problems, right? But if one slave is good, if both the slaves have got good health status, then finally master node selects any one slave randomly, but it won't go up to the last stage, right? Finally, then master node selects any one slave randomly, right? Yes. Master node selects any one slave randomly. Fine. Okay, this is the 4 steps criteria will be followed if for assigning the task T2 to the slave S1 or S3, or while assigning the task, P1 task to be assigned to S1. Why to S1 only means here also the 4 steps criteria is followed. Fine, right, okay. Okay, fine. So this is what. And you can check the message in the chat panel, right, given by the DURGASOFT online team regarding the payment process and the procedure. So in the next session, the link is going to be changed, right? Those who are registered or who are enrolled with the course, only those you are going to get the link, right? Fine. You'll be getting the notes, soft copy of the material and the videos at regular basis. So coming back to our discussion, right? So 4 steps criteria is for this is the 4 steps criteria, right? Fine. Now, so the process of assigning the task T2 to any of the available slaves. Whenever any slave goes down, then the task of that slave assigning to any of the available slaves. This process we call it as fault tolerance mechanism. What is this fault tolerance mechanism? As the fault tolerance. What do you mean by fault tolerance? When multiple tasks are executed, multiple tasks T1, T2, T3. When multiple tasks T1, T2, T3 are executed by multiple slaves. Okay. When multiple tasks T1, T2, T3 are executed by multiple slaves, right? When multiple tasks T1, T2, T3 are executed by multiple slaves, S1, S2, S3. Multiple slaves, S1, S2, and S3, right? Suddenly, if any slave goes down, say S2, right? But suddenly, if any slave then the task of that slave then the task of that slave will be assigned to any one of the available slave. This process is called as fault tolerance mechanism, right? Okay, when multiple tasks are executed by multiple slaves, suddenly if any slave goes down, then the task of the slave will be assigned to any one of the available slave. This process is called as fault tolerance mechanism, right? Yes. So just now I said, right, how can we configure this? How can we configure this replication? We can also configure and increase the decrease the replication size, right? Yes, just now, like here I said, configuring the block size, right? So before this, design principles with respect to replications, right? Design principles. With respect to replication, design principles with respect to replication. Replication is applicable. Replication is applicable. Replication is applicable only to the data, but not for the metadata. Replication is applicable to only to the data, but not for the metadata. Replication is applicable only within the data nodes. But not within the name node, but not within the name node, right? Yes. Same replicas cannot be within the same slaves. Same replicas, right? Same replicas cannot be within the same slave, right? Yes. Observe this third point. Same replicas cannot be within the same slave means, for example, if you are performing like this is master node, these are slaves. S1, S2, S3. So B1, B1, B1 if you are saving in this manner, B2, B2, B2 if you are saving in this way, B3, B3, B3 if you are saving in this way, right? B1, 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 B2, 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 and B3, B3, B3 if you are saving in this way, right? Yes. Okay. So here, if suddenly if S2 is down, right, the B2 block is lost, right? B2 is not present in S1 or S2. Total B2 is lost. So the same replicas cannot be within the same slave. They should be distributed across multiple slaves, right? So this is not. So same replicas cannot be within the same slave. Max number of replicas. Observe this. Max number of replicas, right? Max number of replications equal to number of slaves, right? How many slaves? Number of slaves. Max number of replications depends on number of slave nodes, right? Okay. How many slaves? Those many number of replications you can go, right? So this is what design principles with respect to replication. It's applicable only to the data, but not for the metadata. It's applicable only for the within the data nodes, but not within the same replicas cannot be within the same slave. Max number of replications equal to number of slaves, right? Okay. There is design principles with respect to replication, right? Yes. And one more, configuring, increasing the block size and replication, right? Okay, I'll just copy the same thing here. 1 second. Configuring, increase, decrease the block size and the replication also, right? How can we increase or decrease the replication? Just this property, just I'll paste once again. That is for block size. This one more property, I'll set it here in the same file, right? DFS dot replication, DFS dot replication, right? DFS dot replications. How many? By default 3. If you want to set to 4 or 5 or 2, if you want to increase to 4 or 5, you can increase. If you want to decrease, you can decrease that. This is what the number of replications is. Understood, right? Yes, this is what the replication and fault tolerance set. If there is no data loss, there is no task failure, there is no job failure. So by using this replication and fault tolerance, we can go with it, right? So in the next session, I'm going to discuss Hadoop architecture, right? Storage architectural components and processing architectural components, right? So next session means tomorrow Saturday, there is no class. Again, we will meet on Monday, right? Monday. Okay, so that we'll be discussing Hadoop architecture in brief, right? Storage architecture and processing architecture, right? Right. So any queries you have got as part of today's session, anyone, right?
Sir, one question. You told about maximum number of replications is equal to maximum number of slaves, right?
Yes.
Yeah. Like for example, now I have a data of some 1 GB or something.
Yeah, understood. Yeah, understood. But generally, maximum you can go those many, but it's not that if there are some 40 slaves, 40 times you won't replicate, right? Maximum you can go up to that level, but generally depending upon the sensitivity of your data, right? If it is too sensitive, you can go with 4 times, 5 times, or 6 times replication, but you cannot go with 20 times replication where that data file is very bigger files, keep on accommodating. So maximum number of times how many you can go means how many slaves we can have, those many times. But generally, if the data is sensitive, you go by default 3, you can go for 4 or 5, 6 times, right?
What is the maximum, like we can go maximum 5 or 6? Here you have changed the configuration file some down. You have given something 4 there.
Yeah. By default, it will accept only 3, right? By default, it will accept only 3. But I want a 4 or 5 or 6, right? In that case, you can change how many you want. You can just change it here, right? Yes.
So maximum we can go up to 5, 6 like that, or it is based on
data.
Any data requirement.
Based on the importance of your data, right?
Okay.
Fine.
Okay. Thank you.
So we don't have classes on Saturday and Sunday, correct?
Yes, sir. Saturday and Sunday we doesn't have class.
Okay, Monday to Friday. Okay.
Yes, Monday to Friday, right? So next class will be on Monday, right? You can. So, but Monday the link is going to change, right? If you are registered, if you are enrolled, then only you will be getting a link to your mail IDs, right?
Right.
Fine. And also you can just give a call to this. Once after the payment process, you need to give one screenshot to that DURGASOFT online team. Okay. So to which mail ID means the mail ID where you already got some mails, I think, right? So this DURGASOFT online training is at gmail.com, right?
Right. I sent to them, but I didn't get any reply. Okay. Okay, let me see. Yeah.
Fine. Okay. Everyone, you can just give it to this mail ID, right? Yes. Fine. And even you can give any call, right? If you got any members of this online team for any discussion, right? If you're not getting the video or if any other, right? You can just take these numbers. Okay, this is the mobile number, right? can just make a note of this. Right? Just I'm pasting in this chart panel. You
Yeah.
can just to give a after you are supposed to give that screenshot to that number, right? So they'll be messaging you. They will just forwarding you that if the link is changed, they'll be forwarding the same thing. Okay?
So when can we install this Hadoop and everything in the machine?
So in the next Monday or Tuesday class, I'll be demonstrating. I'll be forwarding, right? Once you got enrolled or registered, for those the software will be forwarded, right?
Okay.
The Google to the Google Drive, right? Okay, fine.
Yeah. So it is like almost 3 months course, or it will be less than that, or?
So sometimes like I'll be taking some Saturdays, right? Saturdays sometimes I'll be taking some bigger sessions. So in that case, I can complete within 2.5 months.
Okay, okay, sir. And sir, I'm from a non-IT background, and I know only basics of SQL. Is it okay, like if I cope up all the things?
Not a problem, right? Okay.
Yeah. Okay, thank you.
And stopping here for today. Meet you on Monday, right? Fine.
Bye, sir.